But the moon landings are portrayed as being real. They're documentary. It's a record of an event which occurred. And that's what we are expected to believe. But the point is that documentary evidence can be as fictitious as Hollywood at its finest. It's perfectly possible to do it. Now, about 3 years ago, a film was posted onto the internet. It was called Make Believe Smoke and Mirrors. It was 2 hours 44 minutes long. It was an extremely technically advanced piece of filmmaking, and it purported to show how the whole Apollo photograph sequences, film sequences were created. And it was done in a very sophisticated way. I mean, most people will say, well, if you film something at double the speed and play it back at half the speed, you get what would appear to be slow motion.
Overcranking, they call that, yes.
Overcranking. Now, that's a very simplified version of what was identified, that there are 7 different slow motion speeds in the Apollo films, depending on where the astronauts happen to be in relation to the camera. Were they close to the camera? Were they far away from the camera? There's a piece of equipment called an optical printer. An optical printer, you can take film and you can duplicate that film. If you shooting at, say, 144 frames per second, which is quite fast, using an optical printer, you can extract every other frame, or every 5th frame, or every 10th frame, and project those as if it was the real thing, because nobody can tell the difference.
This overcranking, this slow motion, is to replicate the zero gravity in or near zero gravity in space.
Yes.
Did they have those optical printers, though, in 1969, Marcus?
Yes, they did. Oh, yes, they existed. They were being used. It was being transferred from film onto video, and that existed as well. It's an extraordinary accomplishment. If what this film, Make Believe Smoke and Mirrors, shows is real, it explains exactly how the whole Apollo deception was carried out. Now, as to the reasons why it needed to be carried out, I mean, that was maybe a separate discussion, but there were very valid reasons why it had to happen. Primarily because they couldn't actually get astronauts onto the lunar surface for real and back again alive, because they didn't know how to protect them from the radiation which we know exists in space, the galactic cosmic rays, the solar particle events, all the problems that humans would have in space once outside the protection of the Earth's atmosphere and the Van Allen radiation belts. Because that has only ever happened on Apollo. If it was that easy to do it, don't you think that the Soviet Union might have done it, China might have done it, India might have done it, Japan might have done it? Of course they would.
One would have thought that since 1973, that was the last Apollo mission, one would have thought that in those 47 years, we would have done better than just an unmanned mission. Which begs the question then, I suppose, why wouldn't the Russians... because, they were supposedly defeated in the space race during the Cold War. Why wouldn't they have blown the whistle on NASA?
That's a very good question. That's a question that's probably the most frequently asked question. And the reason is very simple. Why would they have blown the whistle? Would it embarrass the Americans? No, it probably wouldn't. They'd just say, oh, you're sore losers. We beat you to the moon, guys. Get over it. There are other political reasons as well. Primarily because Apollo was a political mission, as announced by John Kennedy in May 1961. We're going to land a man on the moon before the decade is out and return him safely to the Earth. They didn't know they could do it then, had no idea. Alan Shepard had been up 100 miles and come down. That was the extent of American human spaceflight. Now come forward a few years, and the Soviet Union has one major export, and that's natural gas. It has some oil as well, but natural gas is the main one. What date was the first major contract for the supply of Soviet Union natural gas into Western Europe? Don't forget the Cold War's going on at this time. But here they are about to sign a contract to supply West Germany, Hungary, and Italy with natural gas. September 1968. Do you think that the Soviet, which were, let's say they'd had a very unpleasant experience during the Second War, do you think they were going to jeopardize this good export market, which would help the whole country? We're saying, oh, a few Americans prancing around on the moon, don't believe a word of it, but, we prefer to get the money for our natural gas. Of course they're going to do that. They're pragmatic people. They're not going to make any big song and dance about it. They knew perfectly well that no American had landed on the moon. What was the point of upsetting them? America were a powerful country. They still are a powerful country. They don't like coming second to anybody.
Now, it would seem to me that it would be pretty easy to put this whole discussion to rest. We have in the Chilean Andes in South America, the VLT, the Very Large Telescope. Supposedly, they could train that on the moon, on the surface, and it would enable them to see the flags and the footprints and so forth and all these things that were left behind. Why don't they do that?
That's a sensible suggestion. In fact, that was an article that I contributed to, published about 15 years ago when the VLT, the Very Large Telescope, was being developed. And they actually said, when we're going to test our telescope, we're going to train it on the moon and see the Apollo landers there. And that was 2002, that was. So they've been spending a long time testing it, but they haven't actually identified anything on the lunar surface. The Very Large Telescope is actually now an ULT, an ultra-large telescope, which is supposed to be even better. It doesn't have the resolving power to be able to identify an object 10 foot high, which is what the lunar lander is, at a distance of 240,000 miles. The same applies to the Hubble Space Telescope. That doesn't have the ability to see something of that size at that distance.
What about the Lunar Reconnaissance Orbiter?
Ah, glad you mentioned that, because that has the ability to see them. And in 2009, 2010, it was launched in 2009, it took photographs of the lunar landing sites and all the bits and pieces that were there in 2010, and it was actually lowered down from its orbit of about 50 miles. It was lowered down to 15 miles above the lunar surface to photograph the Apollo landing sites, which it did. And you can see the photographs. They're on the Lunar Reconnaissance Orbiter website. And it shows all 6 Apollo landing sites. There's a problem, though. In order to know what you're looking at, NASA have had to put large arrows saying lander or rover or flag or lunar surface experiment, because you can't see a thing. And this is totally ridiculous. You've probably looked at Google Maps and looked at your own house, and you can probably see a car even parked outside.
Yes.
And if it's got a sunroof, you'll know which way that car is pointing. Now, a few people might say, but Google Maps don't use satellite photographs all the time. They use high-flying aircraft. Yes, they do. So I decided to find a satellite photograph taken, in my case, of London, because that's near where I live. And I found a very good photograph taken by the GeoEye-1 satellite, which orbits at 450 miles above the Earth's surface, photographing through 75 miles of the Earth's atmosphere with the dust and pollution and the distortion that would create. And you can see individual cars on the ground. You can even see people on the ground. But the Lunar Reconnaissance Orbiter, which had photographic equipment on board, which was able to photograph things at the same resolution as the GeoEye-1 satellite, i.e. 0.41 meters, just over 2 feet, that was its resolution. The Lunar Reconnaissance Orbiter had the same resolution. It could photograph objects of 2 feet across. But the photographs that have been displayed to show the Apollo landing sites, you don't know what you're looking at. They're little blobs. They're not distinct objects which you see in this case, in London. You can see individual cars, you can see individual people. It's a photograph of the London Eye, so you can see individual capsules on the London Eye. And it's in colour. The Lunar Reconnaissance Orbiter photographs are in black and white. What's going on?
That is a problem.
It's a major problem, because NASA are trying to persuade us that they have photographed the Apollo landing sites, but you can't identify anything on them at all from 15 miles away. I mean, through the vacuum of space. It makes no sense whatsoever. And anybody who claims that they are definitive proof of the landing is talking through their hat, because they're photoshopped. It's obvious. If you know how to identify a photoshopped image, you can see it is. All right, so they put the captions and the lettering on it. Maybe that's photoshopped. But you can't see individual prints. You can't see individual tracks on the lunar surface. NASA claimed to show individual tracks. They're as wide as the lander. What are they, giants or something? Ridiculous. It's such a ridiculous idea. They're desperate to prove that they landed on the moon. Why don't they just hold their hands up and say, okay, it was a Cold War effort. We had to demonstrate to the world that America were technologically superior to the Soviet Union. We did it. We landed on the moon, or we said we did. Everybody believed it. We won the Cold War. The Soviet Union collapsed. It's now the Russian Federation. Let's just move on. Let's solve the problems of space, and let's stop mucking about with ridiculous ideas of sending humans to the moon 50 years ago. It never happened. Forget it.
You lecture on this, you go right into the belly of the beast. Didn't you speak to before the British Interplanetary Society?
Oh, yes, I did.
How did that go?
Oh, that was great fun. Yeah, I was invited to speak to the British Interplanetary Society, which is the longest established space enthusiasts group, I think you could call it. Founded in 1933 in Liverpool, city of Liverpool. It moved to London just before the war. Arthur C. Clarke was the leading member, very influential member. Patrick Moore, the astronomer, who recently died, was a member. Many important people within the space industry. Neil Armstrong was an honorary member of the British Interplanetary Society. Anyway, I was invited to speak there. This was in 2012, just before the London Olympics. I was invited to speak, and it caused a terrible stir online. A lot of people said, how dare the venerable institution invite a hoax believer? Apparently, I'm a hoax believer. How dare they besmirch themselves with somebody like this? So anyway, I agreed that I would discuss only the photographs. I would make no comment about any of the Apollo landings or anything like that. I'd just look at the photographs and show the anomalies which I identified in the photographs, which I'd done. There had been several of that, and that went quite well. And they were very respectful. They didn't jeer me, didn't throw anything at me, and they asked very, very intelligent questions. But at the end of the day, I was put up against somebody who would refute everything I had to say, because he was a knowledgeable space enthusiast. So that I was looking forward to this, because I thought, well, if somebody's going to show me that I'm wrong, tell me I'm wrong, show me why I'm wrong, I want to hear it. Because if I've got it wrong, then I should shut up and go away and do something else. But I wasn't, because this person didn't in any way, shape or form refute anything that I had said. In fact, one of the questions was, why didn't this person refute what Marcus said? I haven't heard anything against what he said. Was what he said true? So it was a bit embarrassing. Anyway, I joined the British Interplanetary Society. I've been a member ever since, and it was at the British Interplanetary Society, as I said at the beginning of the show, that I heard this talk, which made me realize that vacuums have serious detrimental effects on photographic film. And ironically, one of my good friends lives very near Toronto, Scott Henderson, and he's very enthusiastic Apollo researcher. And he decided to look into it as well, introduced me to a friend of his called Bob Williams, who went out and bought a vacuum chamber to do the testing. There's another person who lives in Toronto, it's called Randy Walsh, who's written a very, very good book on the subject. Not to do with vacuum, to do with the inadequacy of the Saturn V rocket. It didn't appear to be able to do what it was claimed to do. And if it was such a wonderful piece of kit, which would launch 130 tons into lunar orbit, how come 50 years later they still haven't got a rocket that'll do better? The Space Launch System will only launch 130 tons into Earth orbit. So NASA appear to have gone backwards. And the interesting development recently where Vice President Pence announced the return to the moon by 2024 and they've already put it back 4 years. We can't do it by 2024. We need more money. We need more people. We haven't got enough time. Hang on a minute. It took Apollo 7 years from a standing start to allegedly landing on the moon, and you can't do it again with all the technology of the last 50 years. You can't get back to the moon in less time than it took Apollo to do it. What's going on?
They've pushed it back to 2028, is that right?
Yes, they pushed it back to 2028. It's called Artemis, this program. Artemis was Apollo's twin sister. So they're presumably going to put ladies on the moon. Well, they've got to get some spacesuits for them to wear, because they haven't got those yet. And spacesuits are a bit of an important part of the kit to get onto the lunar surface. So I don't see President Trump being particularly pleased, being told that he can't achieve something which occurred 50 years ago.
Speaking of spacesuits, how does air conditioning work in the vacuum of space? How would they keep cool?
Well, air conditioning doesn't work in the vacuum of space because there's nowhere to dump the heat. The vacuum of space is a very good insulator. The only way to remove heat from a spacecraft or a spacesuit or from anything is radiate the heat away. It's something called the black body radiation temperature, where you use the Stefan Boltzmann constant to work out what the temperature of any body in space is going to be. And it depends on the amount of radiant energy being absorbed by that body and the amount of radiation of heat away from the body. There will be a point at which the two are in equilibrium, i.e. there's as much heat being radiated away as there is being absorbed. And you can do the calculation, and if you take a spacecraft, a lunar lander, you know how much heat is being absorbed by it, you know how much heat it can radiate away and the time it would take to do that, and you can calculate the internal temperature of the lunar lander. And this is science, this is physics, this is straightforward calculation, and the answer is 240 degrees Fahrenheit, hot enough to cook a chicken.
Mm-hmm.
Because you can't have an air conditioning unit in space. It doesn't work. There's nowhere to dump the heat. Therefore, you can only radiate it away. There doesn't appear to have been enough heat radiated away, certainly not in the spacesuits, because they were recirculating the air inside. You can remove heat. It's called the explosive decompression of water, where you vent water into a vacuum, and that will remove heat. And that, again, the temperature can be calculated. So you know how much temperature has to be removed from a spacesuit to enable somebody within that spacesuit to operate comfortably, and it would be about 80 degrees Fahrenheit, the internal temperature. So you know how much heat you've got to remove from it. You know the area that the spacesuit occupies, so you know how much heat is being absorbed by the spacesuit, as well as the internal heat from the astronaut inside the spacesuit. So you know how much water you're going to need to be able to remove that heat. And there isn't enough water carried on the spacesuit to do it. There's only about 20 minutes, not 8 hours, as we're told occurred on Apollo 17. So you've got this ridiculous inconsistency with all the equipment and all the vacuum levels. And then you start getting into the vacuum problems of the film, and you realize that the whole thing is a fabrication. Apollo was a fabrication for political reasons.
How does NASA respond to the air conditioning question? I've never heard that issue resolved. What do they say?
NASA tend not to address these questions. When David Percy and Mary Bennett were making their very complex film, What Happened on the Moon, it's a DVD, which looked into all these things, they interviewed NASA. He was the media spokesman. And he was approached and he was asked these questions. He was asked about the photographs. And his response to several intelligent questions was, "We don't have enough time for this nitpicky claptrap." Oh dear, oh dear. NASA is living up to its other name of never a straight answer. So that's the answer to your question. There's never a straight answer.
Right. Now, this is a question I'm sure you fielded ad nauseum, but I have to throw it out there, and that is, how do you keep something like a lunar landing hoax, how do you keep that a secret when, I'm not sure what the figure is, the number of people that worked on the project, but tens of thousands, I'm guessing. 400,000.
Because one of the things that NASA did to spread the load, as it were, They wanted to employ people in all 50 states in America. I don't know if they achieved it, but they certainly had companies working on little parts of the NASA program. There were a lot of things to do. They had to build the rockets and the landers and the rovers and the spacesuits and the control centers. I mean, this was Boeing up in Washington State, Lockheed down in California, the control centers in Texas, the spacesuits in Delaware. Grumman were operating, I believe, in New York, making the lunar lander. So it was going on all across America. And the figure normally quoted is 400,000 people who were working on it. Obviously, some of these were drivers and security staff and secretaries and cafeteria staff, but a lot of them were rocket scientists. So how do you keep this incredible story a secret? You don't. Do you really think that you're going to go along and say to the people making the spacesuits, don't tell anybody, nobody's going to the moon, but don't tell anybody though? Of course you're not going to do that. Everybody working on Apollo throughout America in the 8 years it took to create it were doing the very best job they could. They were working out what they had to do, and they were doing the best job they could. So if you're building a rocket, you'll build the best rocket you can. You want to make it work because you know you're going to watch it take off, because it's all going to be live on television, isn't it? So you can all sit down and watch it and say, well, look, I did a little bit of that, and you're going to be very proud of it. No, there was no big secret to keep. It's called compartmentalization. That is the way in which you know you have enough information to do your own job. You don't need to know anymore. The person building the rocket didn't have any reason to know what the people doing the control center were. People building the spacesuits had no reason to know anything about the rovers. All they knew was they had to build the best spacesuits they could, or the best rovers they could. There was no secret to keep.
All right, let's say hi to Scott checking in from London, Ontario. Scott, welcome.
Yes, good morning, Mr. Allen. How are you this morning?
Thank you, Scott. Yeah, I'm well, thank you.
Yes, I don't want to steal your thunder. I just wanted to say hi. How's the weather? I hear it's windy in the UK.
Oh, it's been very windy for the last 24 hours. It's calmed down a bit now. A few trees got blown over, but that was about it.
There probably had to be at least 40 people in on it, because you have to add in the Playboy bunnies and the golf pro.
Oh, you do? Yes. Yeah.
Yes.
You'll have to explain that one. Sorry, the Playboy bunny. Sorry, that went over my head.
The Playboy bunnies are in the cue cards. They have 3 of them in the cue cards. Instructions on what they're supposed to be doing. They had Playboy bunnies.
Ah, okay, I see. Got it. Go ahead. Did you want to respond?
Yeah, I was going to say, when some of the astronauts were out moving around, they had what's called cue cards strapped to their wrist. And as a prank, somebody had put a Playboy bunny in one of them.
Okay, all right.
A photograph of a Playboy bunny, if anybody can remember those.
I don't, hence my confusion. All right, thank you for that, Scott. Let's say hi to Jim from Toronto.
Hello, Mr. Allen. How are you two?
I'm well, thank you.
I don't know if you guys have seen that movie Ad Astra.
I have not.
No, I haven't yet.
I was just wondering, because it shows them having a colony on the moon. Do you think that's possible in the near future or distant future?
It's certainly possible to have a colony on the moon, but they'll need to burrow underground to protect themselves from the radiation. I mean, first of all, they got to get to the moon. They haven't even worked out how to do that yet. They certainly haven't got a lander. That hasn't been developed yet, let alone designed.
Maybe one more quick question. Why haven't humans actually gone to the moon in so long?
Because it's a very dangerous place to get to. Space is not an environment that humans are designed to survive in.
All right, Jim, thank you for that. Well, let's address the Stanley Kubrick legend that he may have been involved. Does he seem like a likely candidate, the one that would be able to pull something like that off?
Well, Stanley Kubrick would certainly be, shall we say, the top choice if anybody wanted to film something of that complexity. One problem with that is Stanley Kubrick would have insisted on filming on location to get the scene right.
He was a perfectionist.
In my view, there is a connection with Stanley Kubrick. I don't believe Stanley Kubrick had very much to do with the filming. He was a film director. The person who might have not only been connected to Stanley Kubrick, but would certainly have had the skills to do the close model work that was required, and a great deal of what we see on the Apollo films are models, was his special effects director, Douglas Trumbull, or possibly John Dykstra, who worked on Star Wars. These are people who had the skills to do model work, which was what was being used in 2001: A Space Odyssey. It wasn't CGI, they were all miniatures, they were all models. The famous revolving space station you see between the Earth and the Moon in 2001: A Space Odyssey was about 6 foot in diameter. It was built as a model. It was filmed as a model, but it was projected in such a way that the perspective was realistic enough for you to believe it was several hundred feet in diameter and it was floating in space. That was the skill of the special effects director. So whether he did have anything to do with it or not, I don't know, but he would be a top candidate if anybody was going to, shall we say, fabricate it. There's something called a snorkel camera. Anybody who's worked on film special effects will know the snorkel camera is what you use if you want to photograph models, and the film which is then projected will appear to be life-size. It corrects the perspective, and that's one of the ways in which you can always tell if a special effects scene has been used, because the perspective appears wrong.
Right.
On a great many of the Apollo photographs, the perspective is correct, because whoever created them knew exactly what they were doing. And in many cases, they were using models. They were using big stage sets. It was about 300 feet, more than 300 feet in diameter, the set. The backgrounds were projected, and that's where the front projection comes in. That's what Stanley Kubrick was using in 2001: A Space Odyssey on the Dawn of Man sequence at the beginning of the film. It was all filmed in studios in the UK. The scene appears to be on the African plains. No, they were photographs, projected. It's a very good way of doing it. You don't have to travel all the way out to Africa to do the scene. You can do it in MGM Studios in Boreham Wood, which is where he worked.
What other photographic irregularities have you noticed that we haven't covered?
Earlier you'd mentioned shadows going in strange directions. One point I should make is that if you use more than one light source on a film, you may well get more than one shadow from the same object, and that doesn't appear on the Apollo photographs. The shadows go in strange directions on some of them, but that is the artifact of using a camera which takes one viewpoint, and we've got two eyes, so we have two viewpoints, so that's why we can get stereo vision, and we sometimes don't compensate enough. Look at a railway line going off into the distance. We know that the railway line is parallel, but we see it as going off into one point in the distance called the vanishing point, and that's to do with perspective. Most of the photographs are correct in what they show. There are some photographs which do show shadows at angles which are much greater than one would expect from a single light source, i.e. presumably the sun. And there's one quite famous one of Apollo 17 where you have the shadow of the astronaut in the foreground, so obviously the sun is directly behind the astronaut, and a little rock about 4 or 5 feet to his right. The shadow for that appears to be at right angles to his own shadow. Well, that can't happen.
Well, again, could that be explained by the irregular surface, and also that the moon itself it's reflecting, but then it's a light source?
Let's say that the moon is illuminated by the sun, which we know it is. And we can look up in the sky and we can see the moon. And it's bright, but it's not too bright to look at. We can't look at the sun because we know that's too bright. So how much light from the sun that hits the moon is reflected from it? And the answer is about 8%, depending on the surface material. The amount of light hitting the Earth and reflected from it is about 35%, because we have clouds which are white and oceans which are blue, which are relatively light. On the moon, we're told there is a special reflective surface which reflects the light, which shows that the shadows are illuminated. And we go back to the famous photograph of Buzz Aldrin walking down the ladder, and he's lit up like a Christmas tree, but he's in the shadow of the lander. So where's that light source coming from? Oh, it's the reflective surface of the moon, we're told. No, it's not. The lunar surface has the reflectivity of a road surface. 8% is reflected. There isn't enough light being reflected off the lunar surface to be recorded by the photographic film used to picture the scene, Kodak Ektachrome film. There is not enough light being reflected off that surface unless there is an additional light source. And that's what appears to be the case.
Let me just throw one more quick one here, and let me get you to respond to this. This has to do with the Van Allen belts, which we were talking about earlier.
Yeah.
I'm just reading here on a website, talking about this gap between the inner and outer Van Allen belt, sometimes called the safe zone or safe slot, is caused by the very low frequency waves which scatter particles and pitch angle. And so that the idea is that the rocket flew through this safe zone, minimizing the amount of radiation that the astronauts were exposed to.
Dear, oh dear. Yes, there's all sorts of wonderful excuses. Yes, there is a separation between the two belts. There's an inner belt and an outer belt. So there will be an area where there is less radiation. But this idea that the astronauts skirted around the belts, so avoiding them, makes absolutely no sense whatsoever, and it's actually a fabrication. Because if you're launching a rocket, which Apollo was launched from Cape Canaveral in Florida, and they flew out over the Atlantic towards Africa, and they would then circle the Earth and come back over North America and go on round. If you're going to do that, and after 2 orbits you're going to then launch towards the moon, which you can see, the moon's visible when you're orbiting the Earth, and you head towards the moon, you're going to reach it 3 days later. Now, NASA have managed to come up with this wonderful explanation whereby they acknowledge that the Van Allen radiation belts are a danger, because they now say that we skirted around them by launching the rockets through the poles, because the Van Allen belts are not effective at the North and South Pole.
Right, they're thinnest there.
Yes, they're thinnest. But there's a problem with that explanation, that you can't just change direction in your rocket. It takes a lot of fuel to do that. Rockets don't have brakes.